So, Professor Chris Welch, welcome back to Full Throttle with me, Dervish, and it's a nice Friday. And how have you been, first of all?
I'm good, Dervish. It's good to be here. I mean, here in France, where we're still in lockdown. Slightly different conditions from from the UK, but
Mm.
you know, um, vaccinations are going a bit more slowly here, I think. So it's going to take, I think, France a bit longer to get to the state where the UK is.
Yeah. So really, I just wanted to talk to you about asteroids. So, first of all, how are we tracking them? That's the first question that's been asked to me, and I'm asking you.
Well, there's a number of ways you can track asteroids. Sort of astronomical techniques. You can track them with optical telescopes,
Mhm.
with radar, sometimes with infrared.
Mhm.
The main problem is that they are very, very small by comparison to a lot of the other things we look at,
Mhm.
and so difficult to detect. They're also not very reflective. They're mostly quite dark, so
Mhm.
they don't reflect much light, and so without a really good network of telescopes, high resolution telescopes, it is difficult. All the
Mm.
time we're detecting more asteroids as as time goes on, as our technology gets better. And so it's an ongoing technological development. The more telescopes, the better the resolution, the more sensitive the instruments, the easier it is to track them.
Yeah.
There's a question, I think that I think it's probably Barack Obama who, at least from a US perspective, started to address was, which ones are of significant threat to Earth, what size,
Yeah.
100-meter wide asteroid,
Mhm.
um, if that was to hit the Earth, that would do an incredibly large amount of damage. A 5-meter asteroid would do, damage locally,
Mm.
for sure, but wouldn't have quite the same wide-ranging effects.
Mm.
So then the question is, how small do you look? Because the smaller you look, the more and more there are.
Yeah.
These are essentially, the material left over from the formation of the solar system,
Mm.
and on one level, you have very large, asteroids, and then you have, orbiting matter,
Mm.
which goes down from there to, to things the size of a grain of sand. Now, if a grain of sand encounters the Earth, well, we're not particularly fussed. It burns up in the atmosphere and we get a nice shooting star.
Yeah.
So, as you get bigger and bigger and bigger, the potential consequences for an Earth encounter,
Mhm.
become more significant. I think, according to statistics, if I remember correctly, something like 100,000 tons of space material falls onto the Earth each year, but most of this is in the form of dust, and we don't even notice it. A couple of times a year, the Earth, as it moves around the sun, moves through clouds of material. This is when
Mhm.
we get the lovely meteorite showers, which are very very nice to look at.
Yeah.
Because again, they're just small things the size of a grain of sand, and we get these
Yeah.
nice shooting stars, and everyone can wish upon a star.
Yeah.
But as they get bigger and bigger and bigger, they get of more concern. Um,
Okay. Have there been any in the past, I don't know, 50 to 100 years that we've been concerned about?
Well, in terms of encounters, yeah. I mean, a couple of years ago, there was that one that came down in Russia. In fact, I can't remember the name of the area, but
Hmm.
that was something big enough to be seen as it entered the atmosphere. We didn't know it was coming. We hadn't tracked it, but because of the Russian habit of having dash cams in their cars, there was a lot of footage just captured that
Yeah.
way, and when it impacted it, it did some damage. Windows got broken, and so on.
Mm.
And so I think that was maybe useful as a sort of a little bit of a wake up call to show that things do fall,
Mm.
from space from time to time.
Mm.
And to a certain extent, that's a bit like, it's a bit like the weather. Sometimes you get good weather, sometimes you get bad weather.
Yeah.
The point here is that if one of these things that is big enough hits us, then it can do an enormous amount of damage, up to and including what's called an extinction level event.
Yeah.
To be fair, as human beings, we should be grateful to one particular asteroid impact. If it wasn't for the one that had, struck the planet and killed all the dinosaurs,
Yeah.
leaving only some, very small mammals to survive, we would not be here. That's where all the mammals and all the humans came from.
Okay.
It's if you like it. I hesitate to quote the Lion King, but it's part of the kind of circle of life in the solar system.
Yeah.
There will be asteroid impacts.
Okay. So when we talk about asteroid impacts, how are we looking at breaking them down before they enter our atmosphere then? What's the, because I know there's some laser talk at the moment. There's some they're talking about lasers in space or something, aren't they?
There's multiple techniques that have been proposed for dealing with asteroids. And at the moment we don't really have any suitable technology to deal with this. So if today suddenly something big popped up on our screens, it would be very difficult to deal with. But the one key thing is the longer ahead the more you can do about it. So for example, there are asteroids where people say, yes, we're going to have a close encounter in 100 years. We can track it. Well, if that became a big concern, then really, if we can just nudge the asteroid a little bit, we can ensure that it doesn't encounter the Earth in 100 years.
How fast are these traveling roughly?
Well, that's a good question. I don't know, to be honest. I'd have to go back and check some of my orbit mechanics. But the point is, they only need a very small velocity change. I mean, because they're orbiting the sun all the time. We're orbiting the sun all the time. All you've got to make sure is that when this one moves through this space, it doesn't coincide with the Earth. It just goes a bit before, a bit after, or a bit above, or a bit below. So it's a very small change that is required just to nudge the asteroid.
Yeah. Okay.
And so if you have enough forward knowledge, then it should be relatively straightforward. You could send a robotic spacecraft to it. A number of ways you could do you could do the nudge. You could take a rocket engine. You could use what's called a mass driver, a kind of electromagnetic catapult, and you could actually maybe dig up bits of the asteroid itself and fire those out the back. Though of course then you add more things floating around.
More debris.
Debris floating around the solar system. But the point is, it doesn't need a very big change. Or you can there's an approach that's been looked at called the kind of gravity tractor, where you have a spacecraft which travels close to the asteroid, and such is the gravitational attraction between the asteroid and the spacecraft, and again that just nudges the orbital trajectory of the asteroid. And these are good techniques, in my opinion, because they're not destructive. Other techniques that have been proposed, for instance, painting the asteroid. If you, I said that asteroids are quite dark. If you paint the asteroid with, say, the equivalent of silver paint and make it more reflective, then the sun's rays will exert a higher photon pressure on it, and again will change its orbit just by a little bit. So these are all ways that don't require the sort of the kind of Armageddon deep impact type approaches of blowing things up, because the other approaches, the more shall we say dynamic approaches, are the sort of thing that you might consider if you get very little warning of the approach of an asteroid. Say it pops up and you find you've got 6 months or something. That's a lot more difficult. So then you can look at trying to physically deflect it with an atomic bomb or something. or possibly to blow it apart. But it's very difficult to do that sort of thing, accurately, unless you've got good knowledge of the type of asteroid, of its construction, because some of these things that we call asteroids, for example, are really just two lumps of thing that have collided and semi-merged.
Yeah.
And then if you give them a big shock, all that will happen is that they will split up again, and then you'll have multiple objects.
Yes.
Two, or in some cases many, and all you've done is to sort of increase the scope of the problem rather than reduce it.
Okay.
So
it sounds like a stupid question. Where is the material from? I mean, it doesn't come from another planet, does it?
No, it's left over from the formation of the solar system. So initially, the solar system was just this big cloud of gas, initially, which then formed, what's called an accretion disk. So you end up with this kind of giant, saucer-shaped disk because the disk is rotating. Very low levels of gravitational attraction between all the matter in it, but enough so that gradually over time, the various atoms come together and they start to form, dust, and then bigger clumps, and then bigger clumps, and then bigger clumps.
Mm-hmm.
Most of that stuff goes to form the sun. Okay. And then what's left over forms the planets and the asteroids and all the other stuff that's floating around. And so that's where the Earth came from. That's where the other planets came from. And at the same time, that's where lots of bits of rubble, if you like, came from.
Okay.
And since the creation of the solar system, those bits of rubble have been, bumping into each other from time to time.
Okay. And what size of an asteroid would not burn up in the atmosphere coming back? I mean, because we know small ones do, but do we know like rough sizes of?
Yeah, because here I have Zoom's doing its funny thing.
Yeah.
Here I have a bit of iron nickel meteorite, Campo de Cielo, which
I can see. Yeah,
it came from an asteroid, in this case a metal one, iron nickel one, and as it entered the atmosphere, it broke up and created, what's called a meteorite field. Where people who want to can go and collect these things and sell them to people such as me.
And that if that hit a human, that would kill him, wouldn't it?
If this was falling out of the sky and it hit you, I guess it would certainly hurt. It depends which bit of you I guess it hit. If it hit you on the head, but generally these things get scattered into the ground and then get sort of dug up later on. In terms of how much damage do these asteroids or can these asteroids do, it depends a little bit on what sort they are. Are they iron nickel, which is very dense, very very heavy? Mm-hmm. Are they more rocky, what are called carbonaceous chondrite asteroids? And of course, ultimately the size and the mass. Looking at something this size, if this enters the atmosphere, the atmosphere is much bigger than it. The reason that these ones are interesting, from my point of view, aesthetically, is because as they've entered the atmosphere, they've heated up enough for the metal to start to melt a bit on the way through. On the other hand, if you were to get an asteroid, tens of kilometers across, encounter the atmosphere, then it's a completely different ball game. The nature of the physical interactions, the asteroid will pass through the atmosphere in a couple of seconds. If it, as it comes to Earth, the atmosphere will not have time to get out of the way. It'll create supersonic shocks. The asteroid will hit the ground. An enormous amount of heat will be liberated. Anything within a certain range will just be instantly burned. There will be shock waves. There will be tsunamis. There will be the equivalent of potentially a kind of nuclear winter for years afterwards. I mean, this is what happened, as we understand it, when
That's
when
interesting.
when the asteroid struck that killed the dinosaurs. There was obviously the effects of the immediate impact, which were pretty catastrophic in the short term. But even in the longer term, if you survived those, because of all the material that was thrown up into the atmosphere, we had the equivalent of a nuclear winter. And so, the temperatures, dropped, massively. Vast amount of the animals and vegetation died, and it was only some animals that survived. And if I understand correctly, the assumption at the moment is that most of the mammals that are currently on the Earth, are descended ultimately from, small kind of shrew-like animals, a couple of centimeters long, that could burrow under the ground, for protection.
Okay.
And pretty much everything else that was larger just died off. I can't remember where I read it, but for example, there were effectively birds at that time, but the only birds that really seemed to have survived were the ones who nested on the ground, because all the ones that nested in trees got killed because all the forests got wiped out in very short order. So it really does depend how big the asteroid is. It's possible to have an asteroid that could hit the Earth and might just take out a town, which would be bad news for the people in the town. Or it's possible that hypothetically for one to hit that takes out most of the living things in the world.
Right. Okay. Let me just change my my chip in my. I don't know why that's happened. It's the first time it's ever happened. There you go. Get back on. Okay. That's it. Sorry about that. Oh, can't fall as well.
No problem.
Yeah, so it's interesting because we had a spacecraft a few years ago, which they said that was returning to Earth, and it was 4 components that didn't burn in the Earth's atmosphere. There was something called reaction wheels.
Yeah.
I think, don't quote me, I think they're made of titanium. Would that sound about right?
They could be. I mean, the purpose of reaction wheels is to provide attitude control for spacecraft, and so they're effectively heavy wheels that can spin in either direction, to counteract any disturbance torque on the spacecraft itself. So they tend to be fairly heavy components, but there is a trade-off when you make reaction wheels, because you can make them out of composite materials which are not so heavy, but you can spin much faster, which is sometimes a benefit, because there comes a point where if you spin a wheel sufficiently fast, the forces generated by the spinning will break the wheel, and the material will just not be strong enough. And so metal reaction wheels are okay up to a point. If you want to spin faster than that, which sometimes you do, because then you can have a lighter massive reaction wheel to launch, then you have to go to carbon fiber composites, glass fiber, maybe, if you're looking for something a bit less high tech. But certainly the sort of things that survive falls to Earth tend to be the heavier and more solid things. So from satellites, if you've got a particular experiment, for example, that might have lead in it, for shielding against radiation. I mean, that's the sort of thing. It's relatively compact, it's relatively heavy. it will survive its fall through the atmosphere. But those things are falling from Earth orbit. So their velocities will be, much lower. I mean, something in low Earth orbit moves at about 7.8 kilometers a second. I can't remember where that's what's at. I don't know. I'm not very good at maybe 25,000 miles an hour.
Wow, that's yeah.
But to compare, okay, you asked me earlier how fast the asteroids are going. So the velocity of the Earth around the Sun, okay, that's almost 30 kilometers a second. So things that are orbiting the Sun tend to be traveling faster. So, if you can imagine hypothetically, an object that was orbiting the Sun, but in the opposite direction to the Earth, those are pretty uncommon, I have to say, because the way the nebula was established meant most things, orbit in the same direction. But you could get a closing velocity of, 60 kilometers a second. And at those sort of speeds, even a small thing packs a hell of a punch just because of the kinetic energy.
Yeah. So when
square the velocity.
So when asteroids hit Earth, who do you call? Because my wife asked me that question yesterday.
It's an interesting question, and there isn't a clear answer. I would. I mean, if you're interested in finding out a little bit more about this,
yes.
There's it's a slightly unusual film by a French filmmaker, but based in London, Nelly Ben Hayoun, and I'm just trying to remember the name of the film. It's something because it addresses exactly this. Let me just Google it a moment. And this addresses exactly that question. Who do we call?
Yeah, because I'll tell you what. The other day it was on the news that an asteroid had fallen out of the sky, and there was a mark on the floor. And apparently these scientists turned up and started, with microscopes and all their equipment looking at it. Then they wanted to dig up the part of the road that it landed on and take it to a museum or something. And my wife said, "Well, who do you call to do that?"
Well, I mean, I guess the road belongs to the local authority. So if you wanted to dig up part of the road, you'd have to check with the local authority. Can we dig up the road for scientific purposes? But in terms of kind of warning against asteroids, the film is called Disaster Playground.
Okay.
And it's and one of the things it addresses is what are the systems for doing this, and there is no proper worldwide system for doing this. I think it's fair to say that people are getting more aware of the dangers of asteroid impact. I mean, although the two films were of mixed quality, Deep Impact and Armageddon did at least raise that topic. And there's now every year there's an asteroid day set up by people who want to promote awareness of the danger of asteroid impacts. So there is an annual asteroid day to promote knowledge of this.
Oh, blimey! Okay, I'll have a look into that and see when that is. Not that I'm going to go along, but I'd like to know when it is.
I mean, it does. It's usually a series of online events. I think it's in June each year. I think, if I recall correctly.
My birthday month. Yeah.
So that'll be coming up soon.
Yeah. That sounds interesting. So, okay. So I guess I think you've answered all the questions that my not only my family but my fans have asked me online. Is there anything that you are doing or you want to let Joe public know about, Chris? Is there anything you want to?
Well, I guess not in the area of asteroid impacts specifically, but I was recently elected to become the president of the British Interplanetary Society.
Congratulations.
I take office in August, and particularly, although it has an international membership, obviously it's based in the UK. It's the world's oldest space advocacy organization. It was established in 1933. So I would say if there are people out there who are interested to find out more about space, I would encourage them to join the British Interplanetary Society. Get the monthly magazine. Plus, there are online talks. I think there's one next week, I think, and other events. We had just this last Monday. We had a conference called Beyond the Moon, related to held on the 12th of April because it was the 60th anniversary of Gagarin's flight, and it's a good way. It's got the society I joined when I was 18 or something like that.
Wow.
Long time ago. Been with it, man and boy, as they say. And it's a good organisation because it has a mixture of people who work in the field professionally, and then other people who are just kind of interested in space and want to find out more.
Okay.
So,
if I wanted to look at stars through a telescope and look at other planets, I remember years ago I went to Cambridge University. I was working inside Cambridge University at the time, so we got a free evening in the observatory there. Where's the best place for kids to go and have a look for a telescope and look at other planets and stars and stuff?
Well, one of the things about astronomy is that there are lots and lots of amateur astronomers around the world and around countries. In fact, it's one of the areas, one of the scientific areas where amateurs can still make a significant contribution. So, a lot of celestial objects end up being found by amateurs. So, I would say the first thing to do is always to find your local astronomical society. If you're in a city or an area, there will be a local society, and normally such societies a couple of times a year will have public sky watching sessions. And they will provide telescopes, and people can come along and look through them. There's an organisation, I think, in the UK, the Federation of Astronomical Societies, which is obviously represents all these astronomical societies, local astronomical societies around the country. That was my first space organisation that I joined. I grew up just outside Dover in Kent, and when I was 13 maybe, I joined the South East Kent Astronomical Society. And I would go along to their talks in the evenings or on Saturdays, and I would go to sky watching sessions. And eventually I got my own telescope, and and that was probably my first step towards ending up where I am today. Although I didn't become an astronomer, I got into other areas of space. That was where I started. So I would say always start with your local astronomical society.
Okay, and where can people find you, Chris?
If we want to find me online, you can find me on Twitter it's at Prof Chris Welch, WELCH, or they can find me on LinkedIn. Same sort of thing. If you search for Chris Welch, you'll most of the time find the music journalist Chris Welch. But if you want to find me, if you search for Chris Welch and space, then you'll normally find me.
Okay. So you'll be back in the UK soon. So hopefully we can next time we meet up, we can do it face to face.
Who knows? I haven't been outside the city of Strasbourg, where I live, in 14 months now. So,
wow.
When I will finally get to go somewhere again, I wouldn't like to predict at the moment, but eventually for sure.
Yeah. Okay. All right, Chris, it's been a pleasure as always to talk to you, and thank you for your knowledge. It's been much appreciated.
Great to talk to you, David, as always.
Thank you very much. Thank you. I'm just going to stop the recording.